Let me know when you start. Okay, this is Mr. Wyrick, and I'm here today to talk to you about the three types of problems that are going to be on your test tomorrow. Remember, it's not a multiple choice test, so you have to know how to do these, not just pick them from a set of answers. So we're going to start with reducing radicals. Again, this is the sheet that you had. So what we're doing is the birthday cake method here. I've got an 18. What goes into 18? That's 2, and that will give me 9. So 9, I can split into 3 and 3. My pairs, I have a pair of 3's, so that's a single 3 on the outside. This 2 is unpaired, so it stays underneath. That's 3 square root of 2. If you get something that's bigger, like this 175, just remember if it ends in 0 or 5, it's divisible by 5, so I can start with a 5. When I divide 175 by 5, I'm going to get 35. When I divide 35, I'm going to divide that by 5 and get 7. This is a part where if you're dividing these, you can use your calculator on this to do this, and it won't lead you astray. But if you just type this in on your square root on your calculator, you're going to get a decimal answer that's not going to help you. The decimal answer is not correct. There's a pair of 5's, so that 5 goes on the outside. Stuff that's paired up goes on the outside. I heard another math teacher talking, it's like, if you have a date, you can go out. Okay, so that's on the outside. This person, no date, staying inside. Okay, 5 square root of 7 is the equivalent of the square root of 175. You can also check these in the calculator. You can type in the square root of 175 and type in 5 square root of 7, but just see if they come up to that same decimal answer. The other one that I want to make sure I want to go over is, I've seen this over and over again. When we have the square root of 64, 64 is a perfect square. The answer is 8. It is not the square root of 8. No, no, no. Just 8. You don't have the radical anymore. Okay? The next type of problem that you're going to run into, I'll go ahead and come over here to this page, is going to be ones like this, where it's a number plus or minus a radical over another number. Very important on this that you do first reduce the radical. So in this case, the square root of 4 is just 2. So I'm going to rewrite this as negative 8 plus or minus 2 over 2. I've seen a lot of people take this one, just divide them both by 2 and call it done. But because these are whole numbers, you can take it a step further. Negative 8 plus 2 is negative 6 over 2, which is negative 3. And negative 8 minus 2 is negative 10 over 2, which is negative 5. So you get two separate answers there. You need to make sure you address both of them. However, when we come over here to 22, this is another type of problem that you're going to see. This square root of 27, I'm going to reduce that radical. That's 27. 7 plus 2 is 9. 9 is divisible by 3, so this is divisible by 3. 27 divided by 3 is 9. 9 divided by 3 is 3. I've got a pair of 3's, and I have a 3 left underneath. So this is negative 6 plus or minus 3 square root of 3 over 15. Now, this square root does not go into reducing this as a fraction. So you look at your coefficient and then the other two numbers. If they're all divisible by 3, or if they're all divisible by any number, you can reduce this fraction. These are all divisible by 3. So it's negative 2 plus or minus 1 times the square root of 3. We don't change this. It stays exactly the same. And that's over 15 divided by 3 is 5. Okay? When you come down here to ones like this, 243 is divisible by 3. That's 81, which is divisible by 3. It's 27, divisible by 3. It's 9, divisible by 3. It's 3. That's a pair of 3's and a pair of 3's. When there's more than one number, either outside or inside, you have to multiply them. So that's 3 times 3 is 9. So this square root of 243 becomes 9 square root of 3, and it's over 6. In this case, the 9 and the 6 are both divisible by 3. I could reduce that, but the 5 and the 6 are not. Since one of the 3 is not divisible by 3, I'm not going to reduce it. It stays that. That is my final answer on that. Now, when it comes to these equations right here, you're dealing with the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. It's to the tune of Pop Goes the Weasel. If you want to sing, you can look that video up on somebody else's YouTube channel. Okay? But this is A, this is B, this is C. So it's negative 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 7. All I'm doing is subbing in the A, the B, and the C. And that's all over 2 times 2. Okay? Now this is going to be different for every single one because the numbers won't be the same. But the pattern will always be the same. It will always fit into this equation here, this formula. So I'm going to move this forward and say it's negative 4 plus or minus. 4 squared is 16. And then it's minus 4 times 2 is 8 times negative 7 is a negative 56. And that's going to be all over 2 times 2, which is 4. 16 minus a negative 56 is going to be 72. So that's negative 4 plus or minus the square root of 72 over 4. Okay, now this looks like the ones that I was doing before over here. Okay, it's in that same form, so I need to do the steps from there. When I go on the steps from there, here's my 72, that's divisible by 2, it's 36, divisible by 2, that's 18, divisible by 2, that's 6, divisible by 2, that's 3. I've got a pair of 2's and a pair of 2's, and then here's my 3 that's unpaired. So that's negative 4 plus or minus. 2 times 2 is 4 on the outside, a 3 left underneath, all over 4. All of these are 4's, so I can reduce this fraction. In fact, I can just flat out divide. Remember, this is going to stay the same into my final answer here. Negative 4 divided by 4 is negative 1, plus or minus 4 divided by 4 is 1, square root of 3. You can either have 1 square root of 3 or just the square root of 3. Either way should be fine. And we'll go ahead and address, gosh, some of those are too big. Okay, I just want to get this done kind of quickly. Here's A, B, C. So again, negative 6 plus or minus the square root of 6 squared minus 4 times 3 times 10 all over 2 times 3. Now in this case, I'm still moving forward, so I've got a negative 6 plus or minus 6 squared is 36 minus 4 times 3 is 12 times 10 is 120 all over, this would be 6. 2 times 3 is 6. Now 36 minus 120 is going to be a negative 84. So I've got negative 6 plus or minus the square root of negative 84 all over 6. So that means that this is going to be no real solutions, because you can't take the square root of a negative unless you start talking about imaginary numbers. And we haven't gotten to imaginary numbers yet. That'll be in Algebra 2. So stop right there and write no real solutions. Okay, so hopefully this cleared up any questions that you have. It gave you some examples to work from. If you still don't get it after this, make sure to show up to your math tutorials in the morning or at lunchtime, and good luck on the test.